All right. Oh, you can see my legs. All right. So today, pardon the music in the background, but I just feeling the groove. The link for the royalty-free music, so I don't get delisted from YouTube, is in the description. Just found it. So today we're going to be talking about homework 4, homework 4, question 7, homework 5, question 10, 11, and 12. And for the 10, 11, 12, I will do my best not to give everything away. So let's start. Got lots of paper, so we're good to go. So let's see. Question, so let's do homework 4, which is already passed, so we can do the whole thing. So homework 4, question 7. Let's see, check the levels. Can you guys hear me? Maybe a little more gain. How's that? Oh, so much better. All right, let's rock. Manufacturer receives a certain component from a supplier in 10 units. So there's 100 units. And then 2 units of each shipment are selected. So select 2. Suppose it has 5 defective units. So 5 defects. And we're looking for A. Construct a probability distribution for the number of defects. So we're looking for something like this, where X is number of defects. And then B, we're looking for probability shipment is accepted. What was the condition to be accepted? No defects. Alright, so this is the basic setup for the question. There's 100 units, 5 of them are defected, we select 2, we build a probability distribution, and then we check if it's what's the probability that is going to get accepted. So let's start with the basics. Let's build this. So A, we're going to build this, and we're going to build this like that. Well, so how many defects can we have? We have 0, 1, and 2. Why only 2? Because we only select 2. Right? Our n equals to 2. That's all we can do. So 0, 1, and 2. Alright. Alright, so now the probabilities. The probabilities are getting a little bit trickier because we have this to deal with. Right? So we have 5 defects in total of 100 units. Right? So we need to start building building this out. I like the tree diagram, so let's do the tree diagram. First choice, let's go defect, no defect, right? Defect, no defect, right? And so we have this first choice, and here we're going to assign some probabilities. What's the probability of a defect? Well, 5 out of 100, right? So that's 5 out of 100. What's the probability of no defect? 95 out of 100. That's the first choice. And then the second choice comes, we're picking the second unit. Defect, no defect, defect, no defect. Right? So now what's the probability of we picking a defect? Well, we already picked a defect, so that's 4 out of 99. What's the probability of picking a non-defect out of this? Well, there's... how many things are left? Well, there are 99, right? How many of those are no defects? Well, there's 95 still. right? And then again, non-defect, and then we're picking a defect where there's still 5 defects, but there's only 99 marbles, and no defect, it's 94 out of 99. So we build this tree diagram, and so how do we get the final probabilities? Well, defect, right? It's this times this, this times this. So on the bottom we will have 9900, and on top we're going to have 5 times 4, so 20, right? Next one, still 9900, right? 100 times 99, 9900, and on top we're going to have 95 times 5, and that comes out to be 475. And let's get no defect and then defect. 95 times 5, 475, and the bottom 9900. And then the last one is 95 times 94, 95 times 94, and that comes out to be 8,930 divided by 9900. Alright, so this is what we have from the tree diagram. Right? Probability of the first slip, and then probability of each one of them. Now there are different ways to do it. Sometimes you write them on the lines. I wrote it out. It's easier for me to visualize, and then I just multiplied all the pathways out. Right? Why do I multiply? Because it's multiplication rule. It's one happening after the other, right? Probability of this happening, and then this happening given then this already happened. That's a multiplication rule. Alright, so we have this. So now we fill this. 0 defects. Well, 0 defects is no defects, no defects, right? We need 2 no defects ones. And that's 8930 divided by 9900. If we want to do in percentages, that's about 90.20%. That's not bad. Right, one defect. Well, one defect is either we go this way or we go this way, or addition rule. So we need to add these two together. So it's 475 divided by 9900 times 2. Why 2? Because there's 2 of them. They're exactly the same. And that comes out to be, well, let's do 5 times 2. That comes out to be 950 divided by 9900, which is divided by 9900, which is 9.596%. Right? So I added those two up right here, and then I turned in percent. And then 2 defects, well, defect, that's 20 divided by 9900. So that's 20 divided by 9900, and that comes out to be 0.12202%. And if we are very diligent, we can check 90.202 plus 9.596 plus 0.202, and we get 100. I don't know if you guys can see it. The lighting is dreadful, but right. Brilliant. Which means that this is a valid probability distribution. And so this is answer to part A. I'm happy with this, but if you want to include the percentages, that's fine as well. So that's part A. Let's put it over here so people can copy. Let's look at part B. So homework 4, question 7, part B. Part B, probability shipment is accepted. What does mean accepted? Right, accept means no defects. Right? It says if either one of the units is defective, the shipment is rejected. Okay, so no defects. No defects means probability of this, which is in our case, and we're done. That's it. That's all there is. The difficult part is just building this. Now, if this is causing problems, let's look at a problem that is similar. Imagine you have 10 marbles. 2 were black. Alright, so we have our marbles. And let's do the same thing. We pick 2. And we need to build the P x P of x probability distribution, right? So if we are picking 2, well, there's some options. You could pick 2, you could pick 2, you could pick 2, or you could pick 2, right? So you could pick no black marbles, 1 black marble, or 2 black marbles. So let's look at the probabilities. If I'm picking 2, what's the probability I'm going to pick a black marble? Right, the number of black marbles is x. So if I'm going to pick a black marble, well, let's see. Black, white. Probability of picking a black marble is 2 out of 10. Probability of picking a white marble, 8 out of 10. So far, so good. So let's say we go this path. I picked a black marble. Congratulations. Now let's look at it. I can pick another black marble, right? Or I can pick a white marble. If I pick a black marble, what's the probability of picking a black marble? Well, it's 1 out of, well, there's 9 altogether, right? So 1 out of 9. 1 out of 9 to get this. Or I can pick a white marble, and in this case, this is 8 out of 9. And you see this, each one of those lines adds up to 1. This is 1. This will add up to 1 as well. So let's look at the other side. Say I picked a white marble, 8 out of 10 chance. What happens if I want to pick a black marble now? What's the chances? Well, there's 2 of them. 2 out of, well, how many are there? There's 9 of them, right? 2 out of 9. And that's to pick a black marble. What happens if I want to pick a white marble now? Well, it's, how many choices are there? There's 7, right? Out of 9, right? And again, these two add up to 1 as well. And so now let's look at the probabilities. Probability of picking 0 black marbles is picking white white. So this is probability of white white. And in this case, right, that's 7 over 8 over 10 times 7 over 9. So that's what, 56 over 90. If I want to pick 1, then it's picking either white black or probability of black white, right? So I'm either picking black white or white, black? Right? Right. So let's see, black white produces what? 2/10 times 8/9, and white black produces 8/10 times 2/9. So 16/90, 16/90. So this will end up being this, because it's one or the other, right? So we either go black white or we go white black. So that comes out to be 32/90, right? 16 plus 16. And the final to black is this times this. Probability of black black, 2/10 times 1/9, 2/90. And again, if you add those three things up, 56 plus 32, 88, plus 2, 90, 90/91. And this is how we know, we didn't make a mistake. So these kind of questions are just combination of, can you set this up in a way that makes sense? And there was a couple decent posts on Piazza that did this explaining, and hopefully this will help anybody who still had questions about it. If this still doesn't make sense, let me know ASAP and I'll figure it out, or we can get together on a phone call and I can sit through you trying to explain it to me this way. Maybe I can find the point that is missing, the little pieces is missing. Alright, so this is how you do question 4. Pause if you want, and I'm going to take it off. Alright, let's look at questions for chapter 5. And from what I understand, that's still due. So I'm going to have to find a way not to explain it completely. So we have a mean, a standard deviation, find the XL, XR for arc symmetry, blah, 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 blah. All right. In that case, let's do a question that is similar. Let's look at a question where we have a mean of 10. Let's say we have a standard deviation of 2. We say find XL and XR, and let's say that the probability of XL smaller than X smaller than XR is equal to, what's a good number? Oh yeah, sorry, I'm talking to myself, nobody's watching me. Alright, so if I'm talking to myself and good number, what's a good number? I wish I had a die here. Good. Oh, I do have dice. Sorry, it's Saturday night, I'm having fun. So let's see. What's a good number? Let's get some. Oh, perfect. We have one die. Oh, actually better. Here, perfect. So we have a die, and let's do it. Feeling lucky, give me a big number. And today's probability is 19. Oh, sorry, you cannot see it. It says 19. So we're doing 19%, so 0.09. Alright. So this is what it is. So how do I start? Well, first of all, the distribution for x is symmetrically located with respect to the mean. So mean is right here in the middle. Now, if I'm going to mark this, I'm talking about x's here, and this is important. And what I'm saying is, hey, I'm looking for some probability that is split around symmetrically somewhere here, right? Right, this whole area, and this whole area is about 19% between those two. And what are those? Well, that's XL and that's XR. So that's the setup. I'm looking for this. What I'm looking for is right, these two. The problem is I cannot, by the way, this is how I design exams. I just roll dice. But the point here is that probability and x don't mix. Either we go x to z to probability, or we go probability to z to x, one way or the other. And right now we have probability. We do have the probability right here, right? And we're going to try to find x right here, which means that what we are left with is this. We need our z, which means that this is not helping us. So let's force this normal distribution to a standard normal distribution, right? And this is z. So we do. Now again, these things will move according to this. These two things will move, but the concept of and the shape of or the profile of this curve is going to move, but this probability is still going to be somewhere here in the middle. That's going to be my 19%. That's still here. Well, now I'm just attached with a z on the left and a z on the right. Alright, so now I have this. So what do I do with this? Well, we can find those, right? Because we do have mu at 10, we do have a sigma at 2, and we have xr, xl, right? So we should be able to find z, right? So we go z right equals x right minus mu divided by sigma. Now hang on, that doesn't work. Well, why doesn't it work? Well, because we both need this to find this, right? So we need two of them. So this isn't exactly working. All right, well, what can we do? If this way doesn't work, this has to work, right? So artistic freedom, somewhere here. This is 0.19. So if I was going to slice it open in half, how big would be this piece right here? So how big would this piece be here? Well, if this whole thing is 19%, right? Then this red piece would be what? 0.095 would be 9.5%. That's one way to think about it, right? And then you just look at half and you can figure it. The other way to look at it is if this is 19, how big is this? Well, if this is 19, right, then these two pieces, let's call them C. They're symmetric, so they're both size C. So 0.19 plus 2C equals to 1. So how much is C? Well, it's 1 minus 0.19, right? I move this to your side. So 2C equals to 0.81. So C equals to 0.405. And that's the important number. Why? Because it's the same number that we would get if we just looked at half. And that's this piece. This is this piece and this piece. Right? So what needs to happen in difficult questions like this is that you need to visualize what are you looking for and where can you get it, right? Now the reason why we are trying to find probabilities in all the missing places is so we can find the border value. Remember, z is a border value. It's a value that splits your graph into we are where we're supposed to be, we are not where we're supposed to be, right? And z is right here in the smack in the middle. So we need to find where it is. And one of the easy way to find where it is to find how far is it from the edge, right? Of course, this doesn't have any edge because it goes to infinity, but it would be nice if we knew, this up to z, or this up to z, or this. Like we need to know, not the middle, right? But all of it. Like, for example, page number for this page is defined as, how far is it from the start, or if we know how many pages are total, how far is it from the back, rather than just being defined by this page somewhere in the middle. So this way we figure those areas out. All right, so where do we go from here? Let's see how far I can move this so you guys can still see it, the progression. All right. Well, stay. All right. By the way, do not call me a nerd for having lots of dice. I have a lot of other things too, like figurines. All right. So what do we do with this information? Well, now let's clean this mess up. This is going to be z left, z right, 0.19, this is 0.405, and this is 0. So we have this. Now, why am I using z's? Well, because z's and p's go together. X's and p's don't go together. That's the way I remember, right? Z's and p's. All right. How do you find this? Well, z-score is in our cumulative probability table, right, or the one you have that I posted in the table packet. This z-score corresponds to the area to the left of the z-score. So what we're looking for is a z-score that's corresponding to this probability. So if we find 405 in the table, 405, we find about negative 0.24. So that's the z-score corresponding to this probability, or at least that's the closest one. All right. So this is this. How do we find this one? Well, this one, because it's symmetric, it's 0.24, or we can look up this probability. How big is this probability? This probability is 0.405 plus 0.19. So together that's 0.595. Well, if we look up 595, again, probability to the left of the z-score, so for this, everything to the left. Well, let's see. 0.9. I get at 0.5948, which is very close to this, I get 2.4. And it works, right? So those are the two z-scores. So now I can get back to this. ZR equals XR minus mu divided by sigma. We're looking for this, we have this, we have this, we have this. So we don't want this, we want to transform it into XR equals to mu plus ZR sigma. And so we plug things in. So XR equals to 10 plus 0.24 times 2. So that comes out to be 10 plus 0.48. So that comes out to be 10.48. That's our XR. Well, let's look at our XL. Our XL equals to mu plus ZL sigma. So that's 10 plus minus 0.24 times 2, and that comes out to be my math skills, 9.52. Sorry, maybe that's better. All right, so we have our two numbers. Right? Again, the progression is, once you visualize it, realize that you cannot get x directly, so you have to find the z-score. You find the z-score. How? Well, by using the probability. There's a couple ways to approach it. This is the one that I advertise, but there's other ways to do it. And once you have this, you clean it up, you fill in the blanks, and then you find the z-scores using the table, or any table for that matter, cumulative standard normal distribution. And once you have that, this is the formula, and then you just. So I hope this helps you with 10. All right, pause, and I'm cleaning it up, and I'm going for 11. Question 11. Score on a national exam are normally distributed. Okay, so this is homework 5, question 11. Okay, let's see if we can find I'm gonna have fun here. Let's see. Where is this? Oh, let's use those. Sure, let's use those. Alright, so let's see. Our exam has a mean of, feeling lucky, ladies and gentlemen, that's our mean. Our mean is 12, 13, 20, 20, 30, 40, 51, 62, 72. So our mean is 72, and our standard deviation is, let's go like this. Our standard deviation is 193, so our standard deviation is 13. All right, and now let's look at the percentiles. We have some dice that will actually show. There's one. So many dice, so little choice. Whatever. Let's go. Percentiles. 26th. Actually, yeah, let's make it a nice number. Let's make it a nice number. I'm really grooving this song. Alright, let's use this one. And our first percentile is 40. So 40th percentile. And let's get a big number. 90. Let's go 90 percentile. Oh wait, that looks like the problem. Oh well, whatever. Let's moving on. It would be fair if I roll the dice and then read it. What am I at the M? Alright, so this is the mean, the standard distribution, and find the score that is the 50th or 40th percentile. Again, those problems are very similar to question 11. They are not question 11. So if you copy and paste, you're gonna burn in hell, because that's just, yeah. But if you copy the methodology and use it, you're brilliant. So this is kind of a step. All right, so first one, 40th percentile. What does it mean 40th percentile? 40th percentile means, well, it means your bottom 40, right? You cut off the bottom 40. Bottom 40%. That's bottom 40%. And what's the other one? Well, the other one is 90th percentile, which means bottom 90. I know, the song is on repeat. Deal with it. Alright, so this is what we have. 40th, 90th, right? Bottom 90, bottom 40. So let's crack it. Well, what does mean 40%? Well, it means that there's some z-score here that's going to be responsible for this cutoff, right? And then from the z-score, we can get to the x. How? Well, x equals to mu plus z sigma. So let's find this. 40, well, we look in our table, and I got 40 at, I got 40 right here at negative 0.25. Negative 0.25. Yeah. And that's my z-score for the first one. Second one, 90. Well, let's see. 90. I got it at 1.28. 1.28. So that's how I found my two z-scores for this and this. And so now how I do the rest of it? Well, the rest of it is this formula. So what is it? Well, in this case, the cutoff score is 72, my mu, plus negative 0.25 times, well, this is my sigma 13. So x comes out to be 72 minus 0.25 times 13, 68.75. So that will be my cutoff score for 40th percentile. What about 90th percentile? Well, same thing. X equals mu 72 plus 1.28 times 13. So 72 plus 1.28 times 13. And I get 88.64. And that's how you find the cutoff score for a percentile. There is one trick in this setup is to go from here to a z and then finally to an x, because we know this formula, we have it written down somewhere. So this step is easy, you just have to find this. Well, this you find by drawing a picture. Once you have a picture, you know which area is of importance, and once you have the area of importance, right, you can actually use the table to find this. Alright, that's question 11. That was fast. Take a picture, pause, whatever, moving on. Alright, question 12, homework 5. Test of a new tire developed, blah 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 blah. That looks awfully similar to an example we did. Alright, let's see what the question was on Piazza. Piazza said the following: I'm having a hard time with this problem, even though it's self-explanatory. I'm not sure what formula I have to use. Help. Anonymous. Alright, Anonymous says we need help. Well, so let's see what the question says. Test a new tire development. How should I to estimated mean lifetime of something? Our mean is going to be 12,000 miles with a standard deviation of what's our standard deviation going to be? The standard deviation is going to be 90 miles. Why not? The manufacturer will advertise the lifetime of the tire, blah, 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 using the large value for which is expected, using the largest value for which is expected that 98% of the times. 98, I don't like 98. Let's see what we can come up with. Yeah, too small. Let's say 82% of the time. So we're looking for a value that's 80% and will last longer than this. So we're looking for a probability that X is going to be using the largest value for which the our X star is going to be smaller than X equals to 0.82. And we're looking for this value. So X star. So we're looking for this value. What we're looking for is some value X star here, for which 82% of the times you're gonna go below. So we're looking for this area, right? We know how big this area is. It's 82%. What we don't know is this. But what we can do is we can convert it from here to here and then have some z to talk about. And again, if you look up the z for 82%, 99.92, you will get this. And now from here to here, that. Right? Again, where's the tricky part? Well, the tricky part is trying to understand what does mean the largest value for which 98% of the time is the tire will last at least that long. Well, this is this part. They say that right. Hang on. At least. I'm gonna have at least 2 beers. Oh, okay, I made a mistake. I did it wrong. Alright. At least, yeah. At least. So what we're looking for. And we're looking for P, where X is at least X star. At least is this way, which means that if at least is this way, then our cutoff point is here, and our 0.82% is here. See, guys, if you watched me, you could embarrass me on stream. All right, so if this is, yeah, at least 2 beers. So if 98% tires will be at least that long. Well, so this is the at least part. So this is our z-score, and in that case, this is going to be negative 0.92. How do I know it's negative 0.92 rather than anything else? Well, because it's symmetric. If 82% is here, then if we move it 82% here, the score is just going to flip. And I am going to check it, because this area should be 0.18, so 18% here. If I look up 18%, 18% is right here. It's 0.1788. It's at 9.92, negative 0.92. So this is this. And so in this example, our X star, so the number we will be looking for would be that. Mean plus the z-score, remember there's no negative here, times this. So this was a mistake, so I'm just gonna go like cha, 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 cha. Alright, so hope this helps. Okay, that's question 12. Quick check if we is having anything no questions for 10 and 11, no questions for 12, questions about grace period. Alright, question of the grace period I can do offline. Hope this helps. So this was question 5, this was question 12, this was question 11, this monstrosity was question 10, and then this was question 7. Alright, let me know, guys, if you need more of this craziness. Cheers, cheers.